Hello, my name is Eric. Today we're going to review some algebra ideas and work through a review exercise that addresses the topic of primarily rational exponents, simplifying radical expressions, dealing with negative exponents, and so forth. Before we begin, there's some properties that we're going to need along the way. And if you're not familiar with these, then how I solve the problems in the review might not make a lot of sense to you. So let's talk about some of these properties. One, you need to know how to deal with negative exponents. So for example, a to the negative k power turns out to be 1 over a to the k power. I have a video where I go through this thoroughly and explain how it works, but a quick example of that would be something like 3 to the negative 2 power. What is the meaning of this? It's not a negative number at all. The value of this is actually a positive fraction, kind of small, but it's bigger than 0. And the idea is, like with any power, the base tells you what factors you have. The exponent tells you how many of those factors you have. Okay, so I'm multiplying with 3's. I have 2 of them. But when you have a negative exponent, it's telling you that those 3's are divisors, not really factors. They are things that are dividing, and they're found in the denominator of a fraction like that, which of course is the same as 1/9, which of course is the same as 1 over 3 squared. That's one example that illustrates not so much why that's true, but what the property says in the first place. Okay? Another property you're going to need in this review exercise is you're going to need to know a little bit about what a rational power is. So if you have, for example, 25 to the half power, do that on a calculator, it comes out to 5 in the same way that the square root of 25 comes out to 5. And that's because this is just another way to write a square root. And we don't have to limit ourselves to square roots. You can also look at cube roots. So for example, if you take 8 to the 1/3 power on a calculator, it delivers an answer of 2. In the same way that taking the cube root of 8 on a calculator delivers an answer of 2. Because in both cases, what these symbols are representing is the answer to a problem like this. What factor multiplied by itself makes 8? Well, it's 2 times 2 times 2. So 2 is the cube root of 8. 8 to the 1/3 power is 2. Okay, we'll summarize that with a little property up here. A raised to the 1 over n power is another way of writing the nth root of a. And here is a related property. A raised to the m over n can also be written as a raised to the 1 over n raised to the m, which is also the same thing as the nth root of a, and then either to the m power inside here, or up here like it is there. I'll put it inside here. Okay, and I'm not attempting thoroughly to explain why these properties work. These are supposed to be review exercises, so I'm just going over the properties that you're going to need to know. And finally, last property you will need to know for this review exercise is property of conjugates. So what are conjugates? If you multiply 5 plus 2 times 5 minus 2 like most people would, you would follow the order of operations and get a 7 and a 3, and 7 times 3 is 21. But it turns out there's another way to do it. you could multiply 5 times 5, 5 times negative 2, and then 2 times 5, and then 2 times negative 2. And it will occur to you, if you slow down and look, that this is negative 10 and this is 10, and that these cancel. And so you're left with nothing more than whatever that is and whatever that is. Subtract it, because this is 25, and this makes negative 4. So what's 25 minus 4? 21. We get the same answer. If we're doing algebraic expressions, we might not have the luxury of doing what's in the parentheses first. So for example, a plus b times a minus b. You will have to go and carry this out, and if you know a shortcut, you can make it go faster. That's all I'm saying. A times a is a squared. A times b is ab. B times a is ba, but you could also write that ab. And finally, b times b is b squared. What's going on here? Same thing as you saw with the numeric example. The two terms in the middle are opposites. They're going to cancel, and in the end, all you have is a squared minus b squared. That's actually the property of conjugates, and we're going to exploit that when we simplify some square root expressions. So remember, a plus b times a minus b is a squared minus b squared. You may have learned that as a factoring pattern in an algebra class, where they tell you that this is equal to that. It's the same thing. Oh, I thought of one more you're going to need to know, and that is the multiplicity of square roots. I'll write it in terms of square roots, but it also is true of cube roots, fourth roots, and so forth. The square root of a multiplied times the square root of b is the square root of a times b. This does not work with a plus sign or a minus sign here, but it works with multiply. It actually works with divide too. So if we come across that, yeah, we're going to come across that. So let's write that one down too. The square root of a divided by the square root of b can be written as a single square root of the quotient of a and b. You could say this as the quotient of square roots is the square root of the quotient. Now, I'll try to keep those properties over there where you can see them, but I'm going to tab to review, and where I work, we call this topic 9. And if you're just tuning in for the first time, my name is Eric. I teach mathematics in a school that is currently closed, like most schools are in the country, or at least in the Northwest, in California, New York, and so forth. I'm putting this information out on the web so that my students can still have access to learning, because I'm sure they're getting bored sitting around the house by now. Okay, topic 9 review. And I'll be walking back and forth quite a bit. Evaluate this expression and don't use a calculator. Okay, let's start right off with what we see here as a negative exponent. That reminds me of this. So apparently I can write this as 1 over 8 to the 2/3 power. And then remember that any kind of, well, you can decompose this to look like that. So that's 1 over 8 to the 1/3 power squared. And we also talked about how this is just another way to write that. So in the case of the 1/3 power, that's a cube root. We had that example today when we discussed properties. What is the cube root of 8? So I'll just put a note here. That's the same thing as the cube root of 8, and that's equal to 2. So this comes down to just 1 over 2 squared, and 2 squared is 4. So I'm getting an answer of 1/4. That's what they want you to stuff in this box here, all right? Okay, if you need to pause the video or rewind it, go ahead, but I'm going to keep this rolling pretty fast. Find an expression that's equivalent to that. Okay, well, what is a fourth root again? It's equivalent to a 1/4 power. So the first thing you could do is you could write 5 to the 1/4 like that. I'm looking through the options over here. I don't see that one. But I could work with this going backwards, and I could rewrite this so it doesn't look like a fraction at all. Just use a negative exponent. That appears to be this option right here. All right? Problem 3, find solutions to 5x cubed equals 1080. I think we probably ought to divide by 5 first. Does that sound reasonable? So divide by 5. Now, you know, my daughter, when she was 11 years old, came up with a rule for dividing by 5. Any number that ends with a 0, this rule works really well. You just knock a 0 off and double the answer. So 1080, you knock the 0 off the end, that's 108, and double the answer, you get 216. Okay, if you don't have all your powers of 3 memorized, at this point you're going to want to reach for your calculator. And there are 2 ways you can go, and they're absolutely equivalent. You can go this way, where you go to both sides of the equation and take a cube root. That will reveal the answer to be 6. The other way you could go is you could go, and you should know this because it's sometimes incredibly useful, not so much on this problem, but you could go to both sides of the equation and you could raise both sides to the 1/3 power. And that calculation would return x equals 6 also. Now, why the 1/3 power? Well, what's 3 times a third? That's 1. So essentially what you have on the left is x to the first. And then on the right, if you need to, get a calculator and it'll give you that 6. All right? This next problem is a little different in that it's got an even power over here. So you have to be very careful. Using either the 1/4 power or the 4th root, the first step on this problem is to do something like this. I'm going to go with the 1/4 power. And the 4th root of 256 turns out to be the same as the answer to this question. What number times itself times itself times itself makes 256? Now, if you type that into your calculator, it's going to give you an answer, and the answer is 4. It's not wrong. It's not wrong that 4 times 4 times 4 times 4 is 256, but so is this going to make 256. Because each of these turns into a positive 16, and 16 times 16 is 256. What am I saying? I'm saying you need to be aware that when there's an even power here, and you go and take a 1/4 power or a 4th root on both sides, you need to write your answer like this. There's a +4 and a -4, so you're going to get 2 real roots out of this. And then I already explained this. 4 times 1/4 is 1, and this is x minus 5 to the 1 power, which is just x minus 5. Okay? So now all you have to do is add 5 to both sides, and you get x equals 5 plus or minus 4, which quite literally is 2 numbers represented by a weird sort of arrangement. It means 5 plus 4 is 9. But it also means 5 minus 4 is 1. And those are the 2 answers. You can confirm that they're answers by plugging them back in here. If you plug in the 9, 9 minus 5 is 4, and 4 to the 4th power is 256. If you plug in the 1, 1 minus 5 is -4, and that to the fourth power makes positive 256. Okay? Scrolling. Problem 5, rewrite this expression and use only positive exponents. Okay, here's a property I did not write down, but you probably remember this from first year algebra. Where can I put it? I guess up here. A to the j to the k is a to the j times k. We've already used that property today, so hope nobody got confused. 2 times 3 is 6, 2 times negative 3 is negative 6, so maybe my first effort would be to write something like that. But then I appeal to this rule, which says if you don't like negative exponents, I personally like them a lot. But the author of this problem doesn't want to see negative exponents in the answer. The solution to that is, of course, just to put them down here in the denominator. Problem solved. Problem 6. Use properties of rational exponents to simplify 6 divided by 6 to the 1/4 power. Okay, there's different ways to go about this. I think what I would do is put a 1 up here as an exponent, because you have the liberty to put that there. Rewrite that 1 as 4/4. And then you remember the rule for dividing powers that have the same base? You don't add those exponents, you subtract them. So you can write this as a single power with the answer, or the exponent of 4/4 minus 1/4, which of course is 3/4. Let's see if that's in the lineup. Yes, there it is. So select that one. Problem 6. I'm not sure you can see down this low, so I'm going to do some more scrolling. Problem 7, use the property of radicals to simplify the expression. Before we do problem 7, I'm going to assume that in your first year algebra or perhaps geometry class, you were exposed to what's called extracting the greatest square factor. This is similar to that, except we're not doing square roots, we're doing fourth roots. So now, for example, if somebody asks you to find the square root of 75, and they told you that's not simple, you need to simplify it, you were probably given, you should have been given, a list of perfect squares. And you don't have to go very far with this until you're, more than half as big as that. Probably could have quit here. We want to find a number in this list that goes into 75 and not the 1, because that's not going to help. 4 doesn't go. No even number ever goes into an odd number, by the way. I don't think 9 goes into 75 because 7 plus 5 is 12 and 9 doesn't go into 12. Cross off that even number. Now, 25 goes into 75. We all know 3/4 in your pocket is 75 cents. So what you do is you rewrite this as 25 times 3. You then use this property, but backwards. That is, you break this up into root 25 times root 3. You remember doing this? The square root of 25, because I was careful to get a perfect square in the first place, has got a really nice answer. It's 5 right on the money. Whereas the square root of 3, I don't know whether you realize this or not, but the square root of 3 is not nice. In decimal form, as much as this calculator can tell me, the square root of 3 is 1.732050808, and I'm not a big fan of rounding that off either. Why not just leave this looking like 5 square root 3? Because then it's exact and it's perfect. It doesn't really give you a feel for how big the whole thing is, but I'm not sure you would have one anyway if you put the decimal there. What does that have to do with this problem? Plenty. Okay, let's get after it right now. When you multiply two like-indexed roots. They have the same index, they're fourth roots, and it's multiplied. You can combine that into 1/4 root of 8 times 8. And everybody knows 8 times 8 is? That's right, kids, 64. Now, 64 is not a fourth power of anything. Okay? 2 to the fourth is 16, and 3 to the fourth is 81, and 4 to the fourth is 256. Nowhere did you hear me say 64 as an answer. But if you go through those powers of 4, okay? 1, 2, 3, 4, 5. I'll give you 5 of them because I know them pretty well. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. And 4 to the fourth power is 256. And 5 to the fourth power is 625. Again, 64 is not in this list, but you know what it is that goes into 64? 16. How many times does 16 go into 64? 4 times. 4 times 16 is 64. So what you're going to do is you're going to rewrite this as the fourth root of 16 times the fourth root of 4. And the fourth root of 16 is what? 2. Because again, 2 times 2 times 2 times 2 makes 16. That's it. That's what they wanted you to do. All right. Now, you're going to need to know this rule way down here, which if you can't see it, basically says, read backwards, the square root of a quotient is the quotient of square roots. That is, you can break this up into root 3 times root 8. I guess that's an improvement. One of the rules of simplifying roots of any kind, we usually use square roots, you're not supposed to divide by a square root. Don't leave a square root in the denominator of a fraction. That's just a rule. Has to do primarily with aesthetics, but in the old days it had a lot to do with ease of calculation. It does not anymore. Anyway, since you have a square root of 8 down here and you're not supposed to have one, to me the easiest thing to do is go back to a list of perfect squares. So you got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. That's probably far enough. What you're looking for this time is the smallest number you can find over here, okay, that this will go into. 8 will go into what? It won't go into 4 or 9 because those are smaller than 8. But doesn't 8 go into 16? Yes. How many times? Twice. So what you're going to do is you're going to multiply by the square root of 2. And you have to do it like this. Because it might not look like it, but this is a non-zero number divided by the same non-zero number. It has a value of 1. And multiplying by 1 can change the way things look in math, but it won't change the value that's there. So yeah, we're just multiplying by 1. And then you're going to multiply it on the top. And you're going to use this property right here, where you just write 1 square root of 3 times 2. And then on the bottom, you're going to multiply the 8 times 2. And look at that. The square root of 16 is 4. So you come up with root 16, or excuse me, root 6 over 4. And you're done. So that's how you simplify that one. That's how you get that square root out of the denominator. And there's other ways to do it, but that's my favorite. All right, we get to a problem, and it may be the only one where you have to know about conjugates. Conjugates, okay? We had a property of conjugates over here, and we're going to do something similar to that. I remember the first time I saw this, I thought it was really hard. But you kids seem pretty smart today, so... the conjugate of 3 minus root 2 is 3 plus square root 2, okay? Because remember, Conjugates are little binomials, so look exactly the same except that one says plus and one says minus, or vice versa. And they have that special property that lots of things cancel when you multiply. You're going to see that right here. But let's take 5 over 3 minus root 2, and we're going to multiply by something equal to 1. Kind of like I did with this problem where I went square root 2 over square root 2. This time it's just a little more complicated. It's the conjugate of 3 minus root 2. So you're going to multiply upstairs and down by that. The top is probably a little bit easier. You just need to think in terms of distribution. Okay, 5 times 3 is 15. 5 times root 2, it's just 5 root 2. There's nothing more you can do with it. That was the easy part. Now, when you get good at this, someday you'll know a very, very speedy way to do this. 3 times 3 is 9. Root 2 times root 2 is 2. And 9 minus 2 is 7. The answer is going to be 7. But if that was a little too fast, let's go back and slow down and show you where the 7 came from. Ready? 3 minus root 2 times 3 plus root 2 is... Okay, 3 times 3 is 9. You heard me mention 9 a minute ago. 3 times root 2 is 3 root 2. Don't get too excited about that because that thing's about to disappear. Right here, I can multiply from left to right or right to left, doesn't matter. You're going to get a minus 3 root 2, which is the same thing you have here, except that one's plus, and that's key. And over here, you've got the square root of 2 times the square root of 2, and a minus. All right, some obvious things are these cancel. Maybe a little less obvious is a square root multiplied by the same square root. Well, 2 times 2 is 4, so I have square root of 4, and that's 2, and 9 minus 2 is 7. That's how I got the 7. Okay, ready for an easy problem? Problem 10 is the easiest problem on the whole page. In problem 10, you're trying to add 2 cube roots of 11. How do you add 2 roots of the same kind? Okay, I'll give you a massive hint. If you can do 9x plus 3x and get 12x, you can do this problem. If you can do 9z plus 3z and get 12z, you can do this problem. If you can do 9 pi plus 3 pi and get what? Yep, 12 pi. Then you can do this problem. So don't think of this as being anything more or less than it is. It's just a number. And all you're really doing is sort of factoring it out. For example, they may have explained to you that these are like terms and you can add them, you have permission. Maybe they didn't explain to you, though, that you can actually factor out an x, and that leaves 9 plus 3, and that's where the 12 comes from. So, same thing on this one. You're just going to go 9 plus 3 is 12 times the cube root of 11. Well, that does it for what we, in my class, called Topic 9. And again, the topic had everything to do with simplifying roots, rational exponents, properties of powers, negative exponents. And I hope you learned something from that. And have a nice day.